Good evening, sir. Sir, I am going to discuss about the term paper, and the topic is durability performance of sustainable concrete incorporating different supplementary cementitious material. So, firstly, I am going to tell about the outline of the overall presentation. Firstly, I will discuss about the introduction. Then I will discuss about concrete durability and its different aspects. Then I will discuss a few durability properties which are major cause of problem in concrete structures and like permeability, sulfate attack resistance, chloride penetration resistance, carbonation resistance, freezing and thawing resistance, ASR, abrasion resistance, acid resistance, fire resistance, and efflorescence. Based on the literature, a few conclusions are given for those slides, and then based on the literature and conclusions, some recommendations for future research are also given, and then followed by references. So basically, concrete, it is globally known that concrete is the second most used material after water. And in concrete, basically the main binder is cement, and which causes 7%, almost 7% of greenhouse gas emissions. Therefore, it is very important to use, and now it is demand of the cement industry also, construction industry also, that the SCM, different SCM materials, in which commonly used SCM materials are fly ash, GGBS, silica fuel, metakaolin, and rice husk ash. These should be used, and then the performance of those SCMs on concrete workability, strength, and durability properties are now, it is in the recent studies are specified. So further I will discuss about the durability attributes, that how these SCM materials affects the durability, different durability attributes. Like these are given some SCMs, and these are commonly used in dam and bridge structures. So the definition of SCM is basically these are aluminous and siliceous material, which itself doesn't have any self-cementing property, but in the presence of calcium hydroxide and water, they form calcium silicate hydrate gel, and which is the main binder material also in OPC cement. So formation of extra CSH takes place when we add SCMs uh, in the cement, and the pozzolana basic oxides are silica and alumina oxide. These are the in higher amount, and which form CASH gel and CSH gel, which binds the aggregates matrix. And apart from silica and alumina hydroxide, there are a few oxides also present, like iron oxide, calcium oxide, magnesium oxide, alkalis in lesser amounts. They are also present, and the activity of pozzolana, like or SCM, depends on the capacity for amorphous content, glass content, uh, like how much amount of alumina silicates are present in amorphous form, and only that amount with lime will react in the presence of moisture and will form cementitious products. So the efficacy of pozzolanas is defined by pozzolanic activities. Now, durability of concrete is the major one of the major concern nowadays for concrete structures, and it is defined as the property with which it can resist various types of chemical and physical damages uh, by keeping its strength, like compressive, flexural, and tensile strength, and its original appearance, aesthetic appearance, during its overall service lifespan. So the durability characteristic of concrete can be enhanced by adding mineral admixture, or they are also called SCMs, by replacing OPC to concrete. And the benefit is twofold after adding of SCM. One is to reduce carbon footprint by reducing OPC content, and another is to improve service life of concrete structures. So now, a few durability attributes are discussed for mortar and concrete, in which first property is permeability. So, in 2004, Safik and Cabrera studied the efficacy of fly ash by incorporating it in concrete, and it was found that permeability coefficient was almost 4 times less for wet cured concrete by after addition of 40% fly ash at climatic condition of 70% relative humidity. And it was also found that impermeability was higher for wet cured concrete than that of dry curing. The major cause it was due to the tighter pore network, because calcium hydroxide occupies more voids and more space within the OPC matrix, and when SCM materials are added in the OPC, the concrete OPC paste, so the formation of CSH gel takes place, and which reduces the pore sizes and the quantity of pores. Therefore, impermeability was increased. In 2010, Tangchirapat and Jatura Pitakul studied the influence of fine palm oil fuel ash in concrete, and it was studied and finally conclude that the permeability coefficient of concrete developed by 30% of FPOFA was reduced from 13.8 uh, into 10 to power minus 13 to 6.2 into 10 to power minus 13. Almost 50% reduction was takes place at 28 days, and the major cause was the fineness, as the fineness of FPUFA was much higher. Therefore, the packing density within the matrix was improved, and which caused the impermeability. In 2013, Ismail et al. Studied the addition of fly ash within the alkali activated slag matrix, and it was found that it modified the permeability coefficient, that is, the coefficient of permeability was reduced. In in 2014, Buniesi added fly ash and metakaolin, and it was found that after making of high performance concrete, permeability was reduced. In Jalol, in 2018, developed SCC mix using recycled aggregate and GGBS, and finally it was concluded that at 15% of GGBS content and 25 to 50% of recycled aggregate, the optimum mix was obtained with lower permeability, as it is shown here in figure 1, that here the GGBS content, the GPS content is 15% in this oval, and when the recycle aggregate is almost 25 to 30%, the permeability is less as compared to the other mixes. In 2017, Amor Srivali et al. Studied the effect of silica fume and fly ash under moist curing condition, and they have used porous aggregate also, and they have concluded that the addition of silica fume and fly ash reduced the permeability coefficient and increase the durability of the concrete structure, can increase the durability of concrete structures. In 2017, Hamza et al. Replaced silica fume with OPC up to 20%, and it was further concluded that at 90 days, water penetration depth of concrete was reduced from 50 mm to 20 mm. In 2017, Moesani et al. Compared the control mortar bits, and it was found that minimum water absorption was obtained when metakaolin, here we can see that metakaolin and RHA